is Keopaseuth, and this is going to be my final project for instrumentation. And the sensor that I chose today is the CHS-MSS. This is my table of contents. What is my sensor? I'm just going to be talking about my sensor, why I chose it. Then I'm going to talk about the logic building and how I brainstormed and was able to make it to that part. And then LabVIEW 2021, I'm going to talk about how I built the sub VI, the VI, and then the physical circuit. And then I'm talking about future improvements where I can make things better. What is my sensor? Well, I'm gonna talk about who I am as a person. As a kid growing up, I always had really bad health problems where I couldn't make it to class. I always had to go to the nurse. I was also overweight, so I developed asthma. And as I developed asthma, it made it really hard for me to breathe. And the thing that was constantly reoccurring to me was, why do I have to live like this, and why does this have to happen? There was a couple solutions that I had. The humidity really affected how I was able to breathe, and light exercise could also control, since I was fat, how I was able to live. I could have a rescue inhaler, and I could have a life alert where it would alert my family that I needed help. But all of these are really more of like light exercise is like a daily life kind of thing, which I really didn't want to do. Rescue inhaler and life alert, those are more like trying to help me after I have an asthma attack. And so I chose to work on humidity control because that is really what's going to tell me that I can kind of prevent it by being in a favorable situation for myself. This is a quote from Scott Adams. Engineers like to solve problems. If there are no problems handily available, they will create their own problems. Well, for me, I didn't really know why I wanted to start on this project, but once I started thinking about how every day it's hard for me to get to class and commute because I have health issues, then I decided that I wanted to do some, and then it related to a humidity sensor. So this is the logic building. This is my process. So on the first day, I just got a piece of paper and I was going to write down what I wanted to work on, what I could work on each and every day. And I decided for the humidity sensor. So day 2, I was looking at the data sheet I found from DigiKey, and then I was able to look at a picture and it had a graph and it would tell me the relative humidity percentage, and I was able to develop a formula for the formula express VI, and my VI I'm going to talk about later. And then on day 3, I built the VI, and after building the VI, I built the physical circuit, and I was able to hook them up together in order to convert voltage to relative humidity. And then on the last day, I tested the build and I recorded the data. So this is the graph that I was talking about in the data sheet. It was able to, what I did was basically I did y2 minus y1 over x2 minus x1. And after taking that value, I was able to put it into y equals mx plus b and find the slope. And then I used that equation and I plugged that into my formula express vi. Now I'm going to be talking about LabVIEW. This is the dirt day. And as you can see, this is all in, except for the white to measurement file, this is all in a conditional loop. So the input from my physical circuit is going to go into my DAC assistant, and that's going to feed into my formula express VI. Now this is going to convert voltage into relative humidity, which is then going to be converted from dynamic data using the convert from dynamic data VI, and then it's going to be set to single scalar, and it's going to feed into the numeric indicator called relative humidity percentage, or RH percentage, and it's also going to go into a waveform chart, which is going to be on the front panel. After the formula express VI, it's also going to go into a collector, which is going to read all the continuous values, and it's going to write those values onto a file inside the PC. After the DAC, there's also going to be converted by a single scalar again into a numeric indicator called voltage. So this is just reading the voltage before and after the formula. And then it's also going to be graphed with using a waveform chart. But after it is converted, after the formula, it also fades into the sub VI called true or false. Now this has a Boolean switch that asks, basically, depending on the case statement, it'll ask if it is a comfortable humidity or not, and that would be indicated by the LED called comfortable humidity lighting up. Now here's this case statement. This reads, if the input is greater than 20 and it is less than 40, then it will read as true and the indicator will light up. If not, false is less than 10 or greater than 40. Those are unfavorable relative humidity percentages, so it will not light up. Now this is the unit interface, or the front panel. Now this reads the voltage on the right, and then on the left it reads the RH percentage graph. Below it you can see the numeric indicators that were on the block diagram earlier, and it will read the numeric values. And then in the middle there's a switch for the comfortable humidities, true or false. And then on the right you can see a green LED that's it's Boolean, it will light up for true or false. And on the bottom right there's a stop. Now here's the physical build. On the physical build, this is my Elvis breadboard. On pin 3 is powered, pin 4 it is grounded. On pin 5, that is going to be the V out that is going to go into the NI205. For the NI205, I use the channel A0, and on the bottom left, the second one, there's going to be a common ground, and I use that to ground the circuit. Now this is going to be the benchtop power supply. I use DC, and then this is where I put 5 volts. Now I'm going to play the video where I was testing the circuit. Now before I play the video, I was going to talk about how I was able to test the circuit. You can't really see it, but the way I was changing the humidity was I was using my breath in order to increase the humidity around the area. And as I play the video, um, it'll switch to the front panel. In the front panel, you can see that the humidity is increasing as it is running. That is because I'm breathing on it and it's increasing slightly, but not too much because the humid breath has its limitations and it will not go that much. That's the end of the video. And now, this is ways to improve in the future. Surface mounted parts. This will go on the PCB, and then microsizing. This can also help in the future. This will help mass production. It'll be cheaper, and then there'll be lots of them, and then they'll be easier for accessibility. Thank you very much. Once again, my name is Keopaseuth, and this is my presentation for the instrumentation final. Thank you for your time. That is all.